Well, hi everybody, and thanks for all the comments on the first video, or was it two? First video or two anyway I've done on this. And so this is the humming, or buzzing. I'd rather say buzzing, you know. Humming to me is kind of what happens when the power supply filter capacitor is not working well. And you get that kind of low hum. This thing has much more of a buzz quality, and I think that's a bit of a hint that has nothing to do with the power supply. It's something else. It's a different phenomenon. This is a very simple amplifier. They don't get much simpler than this. So this is going to be our test case, so I'd like you for the comments. We're going to go through and try a few things. Oh boy. But first, thank you again, Bobby, for this idea. I'm going to do it, and that's take my warped card here, take an old CD, and I'm going to glue the card to the CD here. No, let's do it this way. Yeah, right. Yikes. I'm not sure this is really the best glue to use. Kind of glue against plastic, but I think it doesn't have to do much duty, so I'm thinking it'll be okay. Maybe I won't be able to use this on any jet-propelled record players. That may not work well. It's pretty well flattened out. Look at that. It's gone perfectly flat. This has got some tin in it. It's actually got kind of like a metal. Huh. I feel like that. Okay, so I don't need to do this, but I'm still going to do it because I think it's still a good idea. Because even though I can straighten this out, it's bound to take a beating. This will make it a little more protected. Try and get that right in the center. There we go. Yeah, I'm pretty sure that's going to glue down just fine. I suppose I could have roughed up the CD, but we're not talking about high performance here. Okay, put that under some pressure. Okay, sorry about that. That just took me a little bit. I found a nice paint can to supply the weight for that. Now, this guy is humming. Why don't we get this ready to plug in. And we'll see how that goes. Okay. You know what, the amplifier is in a position here, I guess I set it back like that, where I can't access the parts underneath it, so. There's that sheet of asbestos that I have to be so careful around. Give it more light here. One of the interesting suggestions was to put this on scope, so we will. We'll investigate with the oscilloscope a little bit, see what we can see. Okay, I think everything is safe enough to switch on. Volumes are... doesn't much matter. There's no signal. I think they're turned down. Power on after a quick safety. Okay. Give it a moment to warm up. I'm just going to put the other speaker right here. So that the other speaker sound is coming right in here. And it's going to be good for the microphone on the camera that you're listening to. That was me just putting it on full power. Turn this up a bit. Okay, and that is this speaker now that we are hearing. I don't know, do you find it that crazy annoying? I guess it is. Okay, so first experiment now. We are currently plugged into my isolation transformer, which, and there is some question now about how isolated the isolation transformer really is, which we will check into as part of this video. But the first thing I'm going to do is I'm just going to reverse the plug here and see if that makes any change. Hopefully you can hear this. You must be able to hear that now. So, do this kind of there where you can see it. Okay, there we go. Got quiet. Back in. And my impression of that is it's exactly the same. And now I'm going to plug this into a regular wall outlet. No longer isolation transformer. There it is. Give it a moment just to make sure the tubes are heated well. Well, you know, doesn't sound any different. Now I'm going to reverse it. Okay, well, no difference. So I'm going to put it back in the isolation transformer. Once again, certainly no difference I can hear. So we're left exploring this particular hum. Now, to me, you know, this does sound different than a power supply hum. Heard this kind of sound all my life, so have you, I'm sure. different things at different times. It's not the low pitched power supply hum. It's not that. There's too many harmonics in this. So this sounds like, you know, as a guess, just a wild guess, harmonics coming from how the rectifier, the power rectifier there, how it operates. Wild guess, but we need some guesses here. And another thing that is, I think, really important to understand, and I was thinking about this the other day before shooting this. I had missed it earlier on, but in the end, it finally did spots. This capacitor here. This one here, I think it was a 0.01. It's connected from ground, from, let's call this is not chassis ground. This is the amplifier's electrical ground, if you like. For instance, the negatives of the two power supply capacitors are connected ultimately to this point, too. So, losing my grip here. No, yeah. So this capacitor is connected, and it's connected in a very important way, and so are the grounds on these two wires. So what's important about this capacitor is the lead is not soldered on the inside of the can. It actually passes through an opening. It's a bare wire, passes through a hole there. You can actually see it on the camera there, the one I'm poking on. And this capacitor is soldered to the outside of the chassis. And the soldering is, it's not a blob. It's spread out over a fairly large area. I don't think this is by accident. I think this is by design. Now the grounds on the two signal wires, the left channel and right channel signal wires, that's these two coming in here, shielded wires. They're soldered on the inside of the can in a similar way. It's a fairly large solder area. In these, look, this one has been almost strained to get out to here. So these again are not positions by accident. This is all by design. And it probably has to do with exactly what we're listening to. That's my guess. The hum we're listening to is what all these components are attempting to minimize, work around, avoid, whatever word you want to apply to it. Suppress, maybe not so much suppress. Suppress is tricky, because as you try, this is basically the problem here, is you try to suppress this hum, you also suppress the signal coming from the cartridge at the same time. It's just like turning the volume down. If I turn down the volume, look, the hum went away. Problem solved. Well, no. Not solved at all. So let's get this on the scope. I think that's the next thing to do here. Figure out how to so I'll let you see where I'm making the connections, and then we'll move over to look at the scope. So this is a scope ground. What do you think? What do you think of that? I'm not grounded. I'm making sure I'm not grounded, so my finger's not having any effect. Okay. The existence of this hum kind of calls into question everything we're going to try, but let's first connect right to the positive of the filter capacitor. Just looking for a really good place to clip on here. It's not very good. I have a weak clipper. A weak clipper. So I'm right at the output of the diode, at the top of the first filter, and okay. There we go. Hold on one second here. I don't know why, but that's what we want. Okay, sorry about all that. That's not going to work so well either, is it? You know what? I'm just going to hold it. Nothing like a lesson in bad video production, so. Okay, so there's the output. We got to clean this up a little bit here. This is not helping us. Yeah. Well, that's a signal that sure does need to be smoothed out. I'm not so sure I got this on quite the right spot. Let's just check things out here. And you don't have to listen to that. So, okay. Look up here. Take a look at this. See where I am. First. There we go. Darn, this camera, I really have to. I'm not keeping a close enough eye onto it's focusing. So this capacitor's positive terminal is right here, positive wire, and it's connected right where I got the scope connected, right to this tube. And this is the high voltage feed here. Yeah. Okay, so that should be nice and clean. I would imagine that should be a pretty clean thing, and this is what it is. Now the setting here is 1 volt per division, so that's not a small deal. That's a volt or so. Is that what we're listening to? I don't think so. That's something else. Now, where's our input right here? This might get noisy. Oh yeah, that's really noisy. let's go on there. This could change the whole... No, it didn't. Wow, something not making a lot of sense here. Have a look at this. So there's almost a perfect sine wave there. I'm suspicious that I got this ground in a bad location. If I move the ground from here to here, that red wire they used everywhere. Or perhaps, let's see, there's another black. There, go into there. Okay, better just check this. Seems to be extra loud. Well, yeah, because I got that connection to the scope there. So what I'm doing is I'm just double checking quickly to make sure there's no voltage here. I have done something dumb. No, there's no voltage there. Now this is introducing a hump. This is all part of the lesson here. I'm sure we can learn something from every step of the way here. So just in removing this, well, there's a higher potential on the end of this now. It's just noise. It's not supposed to be there. There's not supposed to be any signal here. If you can see what's happening on the scope, it's miles high. So I'm going to put the scope ground now on the appropriate point. What I think is the appropriate point. There we go. Look at that. Silence ensues.